Hi everyone, and welcome to your first lesson in Python. This lesson is going to attempt to cover several topics, the first of which is variable assignment. And we will also be taking a look at a particular type of object in Python, and that is the number object. We'll see that numbers can fall into more than one category. Remember from the previous video that I went over something called object-oriented programming very briefly. This is a larger topic that you can spend some time on at some point, but at this point all you need to know is that Python code is organized around what we refer to as objects, and that's really anything we talk about in Python, any kind of data that we work with. And an object is going to be associated with a certain collection of attributes or characteristics or properties. Those are all words we use to describe the object: properties, characteristics, attributes. And we also have methods, and those are things that a certain type of object can do. I find this is easiest to understand by looking at a type of object. So what we're going to look at now is variable assignment, but in the context of numbers in Python. Okay. And as you saw in our previous video, we're working in what is called a Google Colab notebook. This is our programming environment. This is where we're going to run our Python code. So there's several processes going on behind the scenes, and we're going to be focusing on learning about different types of Python objects within this environment. So we'll go through and you'll see blocks of text, and then you'll also see blocks of code, and what we can do is run that block of code and examine the output. It'll be somewhat inquiry driven as we go through this, exploratory. And I encourage you to follow along with the notebook because it is designed to be interactive. So any place you see a code block, you should try running it, and also feel free to modify that code as you see fit. So the first thing we look at here is variable assignment. And all I'm doing is it's very simple. I am assigning letter A to have value 3. And if I run this code block, I don't see any output. But what I can do next is check to see if the variable A is associated with anything. And when I do that, when I just run this code block, which is essentially asking what is A, I get back the value 3. Another way that I can examine the value of variable A is to use a function called print. So here you're seeing your very first function in Python. This is a tool, a method that is built into the default Python library, which basically just shows us something. It's a way of saying, show me the output. A couple things to notice about the print function, most notably, is the open and closed parentheses. That is the key way to identify a function in Python. We're going to devote a whole entire week to functions in Python. But basically you can think of a function as a tool that performs some kind of action. Okay. To contrast what we've just seen with the variable we've called A, let's take a look at what we're going to see is our first of many, many errors that we will encounter. We will live in a world of errors. And if we type in letter B before assigning letter B to any sort of value, we get back an error which says name B is not defined. So that's Python's way of communicating to us that there is no value associated with the variable B. Okay. We will learn that in Python, variables are associated with particular data types. And it will be very common for us to check what data type we have. And to do this, we use the type function. So here you are now seeing your second function in Python. Now remember, going back, I told you everything in Python is an object. So when I say check the data type, it's another way of saying check what type of object this variable is. And we're going to get some output that tells us a little bit more about the class into which this variable a falls into. And what I get back is int, and that's short for integer. So an integer in Python is a particular type of object that is associated with a unique collection of attributes and methods. So let's explore those a little bit more in the next section on numbers. Sometimes I have to expand the section, so take a look at my drop down arrows here. Okay, moving into our next section on numbers and operations with numbers. We'll take a look at some of the most common data types that most common types of numbers that we encounter in Python, namely integers and floats. So we just saw an example of an integer. Let's explore floats as well at the same time. And we can use this as an opportunity to see two different types of objects, which are essentially, you can think of them as related, right? They're almost like family members that are their siblings or cousins or something like that, because they are similar in many ways but different in other ways. And that's kind of shows us the nature of objects in Python. A lot of times they have properties and methods in common, and then some specific differences that make them unique. Okay, so within the category of numbers, we'll explore integers and floats, and as you can probably see, an integer is what we commonly understand from math as an integer is just a number with no rational component, whereas a float is an integer plus a rational component. In other words, there are numbers after the decimal point, right? So in this code block here, I'm going to illustrate the two different types of numbers. So I assigned variable a to equal 3. I assigned variable b to equal 3.14. And I am printing variable a, and I'm also going to print the type of variable a. And I'm going to do all the same things with variable b. So this is our first example of multiple lines of code all together. Now, one thing you should note about a Google Colab notebook is that you're always going to be able to ask for output from the last line of a code block. So here, I'll just show you what I mean. So I can just say, what is, let's run this. Okay, so here I get some output, but just notice if I ask for what is variable a in a code block below, I'm going to get 3, because a has been defined as 3. But now if I write a new line below line 1 and ask what is b, just notice this is something that's specific to Colab notebooks. Notice that I'm getting the output for the last line, line 2. I'm being given the value of b, but not the value of a. If I want to see everything, right, if I want to see line 1 and line 2, if I want to see the value of a and the value of b, then I have to, what programmers will often say is wrap both of those in a print, and then I'm going to get both of those outputs. Okay. So that's just a bit of a side note about Colab notebooks, and that explains to you why I've used print statements in lines 2, 3, 6, and 7, because I wanted to see all of that output. Okay, so noticing the results, when I print the type of variable a, I get class int. If I print the type of variable b, I get class float. So Python is telling me the data types associated with those values. Okay, so that's integers and floats. Let's take a look at some of the operations that we can do with numbers. And I generally like to have students take a moment with this exercise and explore. What I like to do is give students all of the symbols that correspond to operations that can be done in Python. So each of these symbols is an example of Python syntax that can be interpreted by Python, and it will perform an operation. And this is going to make sense to you because I think we can probably guess what a plus sign, a minus sign, a multiplication sign, and a division sign symbol are going to do when we're working with numbers. But then you're going to see two additional symbols, this double slash line and then the percentage sign. Those do something different. So I'd invite you to explore what those do. Okay. And when you're asked to explore something, I will encourage you to always create a new code block, right? So I want to model how you should work with this notebook, okay? And I can always just take code, copy and paste. So let's just explore this from scratch, even though I've built a template here for you to use, showing each line of output, demonstrating each of the operations that I'm asking you to work with. Sometimes it's nice to work with each of them line by line, so I'll take this opportunity to show you how you can do that. Let's say I just want to try out the operation x plus y. Probably no surprises here. I get 10.5, which is simply adding those two results together, right? Check out subtraction, 1.5, yes, this all makes sense. Check out multiplication, the star symbol. Yes, that makes sense. And then division, it's going to be a smallish number. Okay, 1.33. All right, so all of those operations seem pretty intuitive to us. Now let's explore the mysteries. So what does the double division symbol do? Double forward slash do. So we'll have, actually it makes more sense to do x divided x, y, almost gave it away. So we saw what x divided by y was. It was 1.33. If I do x double divide, double forward slash by y, what I get back is only the integer component of the division operation that I just did. So this is actually called integer division. Okay, so it gives me the integer component of the number, but not the rational component. And again, I encourage you to try this a little bit more. So rather than just working with x and y, I'm assigning those some values. You can absolutely just type in numbers and see what happens. Okay, with integer division, it's nice to kind of explore what happens with the single division, normal division, and then what's going to happen when we add this additional forward slash and perform integer division. And just convince yourself that this is the case, right? So let's just change this a little bit. Convince yourself how this works and try to predict what will happen. Let's try something else. Let's try divided by 6. Okay, so 17 divided by 6, 2.83. 17 integer divide by 6 is just going to be 2. So we just truncate the number and leave the integer component. Okay. And then lastly, let's explore this percent symbol with our, let's do this with our x and y. And then we'll try it with some other numbers as well. Okay, so I have x, and then I'm going to use this percent symbol, modulus y. Okay, that might not be especially illuminating. So let's try some additional numbers here to see if we can make some sense of this. I'd like to explore these operations because if you do, there's going to be a moment when it kind of clicks for you. So I'll give you some more intuitive examples. So let's try doing 20, and then we'll use this percent symbol, and let's try 4. Okay, 4, that gives us 0. Let's try 5. That gives us 0 as well. What if we try 6? Okay, we get 2. Interesting. So at this point you probably noticed, okay, I divided by 4, I divided by 5. Both of those values go into 20 evenly, right? So 20 is an integer multiple of 4, it's an integer multiple of 5. Well, what if I try another multiple of 20? Okay, that seems to work. What if I try and even the next multiple of 20? Okay, so anytime the number on the right is an integer multiple of 20, I get a 0 as an output. But when that is not the case, I get some kind of, I get a number here. So let's try just a few more. 4, maybe you're starting to see a pattern. 9, you seen it yet? Okay, so here's the deal with this operation. What we're getting is the remainder after division has been performed, okay? So we got 0 as a remainder when we divided 20 by 4. We got 0 as a remainder when we divided 20 by 5. But when I divide 20 by, say, 9, I got 2. Well, that's because if I'm dividing, if I divide 20 by 9, I'm actually dividing 18 by 9, and the remainder is 2. So this is actually called the modulus operator, and the modulus operator gives us the remainder after division has been performed. And that can be a fairly useful operation in a variety of circumstances. When we start to work with functions, you'll see an example where it's useful to use this operator. And there's a way we can check if a number is an even number or an odd number by using this. And basically, all we would need to do is check if there is any remainder when we divide by 2. If there's no remainder, we know the number is an even number. If there is a remainder, then we know the number is an odd number. So that will come in handy in some other examples. Okay. So that I wanted to show you how you can approach these kinds of exercises. Also wanted to show you how you can modify our notes here by adding extra code blocks. Okay. So I can run this code block to see all of the output, but it's not especially meaningful until we kind of break it down one at a time and explore every output. Another thing we can do is comment out lines of code. I'm going to take this opportunity to show you that as well. So if I put a hashtag in front of a line of code, it will be ignored. And I can do this line by line, but I really like to do this quickly all at once, and I can do that with keystrokes on my computer. I can do Control / and I can undo it with Control / on a Mac it's Command /. So let me just show you what this does. This makes every line of code that has a number symbol in front of it, makes sure that code is ignored and only runs code without the number symbols in front of it. Okay? So there I'm just getting the output for line 4. This is how I'm customizing the output here. I'm writing what's called a string, which we'll get to later, so that it's more readable. Okay. So what can be somewhat useful is looking at one line at a time and just focusing on individual operations, individual lines of code. So that's another useful tip you can use as you're working with these notebooks. Okay, so here we have a summary of the operations that we just explored. So to understand the modulus operator just a bit more, since that's the most unusual of the bunch, we can take a look at these examples, and we can figure out if one number is an integer multiple of another. So we'll try this with some somewhat larger numbers. We have 264, and this is not a code block, this is just my text in the example. We can see if that's an integer multiple of 4 by setting x equal to the result of that operation. We do the same thing with 1054, and let's see what we get. Okay, so I'm setting x equal to the result of that operation. So x is going to be the remainder value after 264 is divided by 4, and it's 0. Okay, and I'm checking the type just for good practice. Okay, now let's see if 1054 is a multiple of 4, and I don't actually know that, so maybe I would want to write some code to figure that out. Now, because the remainder is not 0, I know that 1054 is actually not an integer multiple of 4 because I did get a remainder. Okay, so keep that in mind as we get to more involved programs, because there are going to be a couple of questions where you're asked to figure out if one number is an integer multiple of another. It's kind of a common early programming task. And then next we'll move on to a new data type called strings.